Hello everyone, welcome to the next lecture on the probability and statistics. Today we will discuss about the strong law of the large number and we will explain it with the help of various numerical examples. Myself, Dr. Garg, working in the School of Mathematics, Thapar Institute, India. You can contact me, either of my email IDs are there, else simply follow this channel link, Dr. Harish Garg. So what we have discussed so far is that we already discussed what is the weak law of the large numbers and how you can solve them. So I can quickly recall that what is the weak law of the large number. If you have the sequences of the random variable xi's and the corresponding mean as a mu I, then the average, you can see that this is nothing but the average of these sequences. It will converges in probability to the averages of this mean, provided this condition will hold, where Bn is nothing but the variances of their sum of the variables. What is that? P is meaning that this is meaning that convergence in probability, and we already discussed in our previous lectures what is the meaning of the convergence in probability. So xn converges to alpha in probability. It means whenever you take the limit n approaches infinity, probability of that number is lie in the neighborhood of epsilon is a 1, or else if you write as a greater than is a 0. So this is the convergence in the probability and the weak law of the large number. Now we will discuss about the strong law of the large number. So what is the meaning of the strong law of the large number is, if you have the sequences which are the IAD and have their expected values xi's, then this is the mean of the random variable, that is converges almost surely. What is the AS? AS is called as the almost surely. So while in the weak law of the large number, it converges in the probability. How it is differ? So to understand this strong law of the large number, we firstly need to understand the meaning of this almost surely convergence in the probability. So we will firstly describe what is the AS meaning, and then once we will try to understand this AS, then strong law of the large number will be very easy. So what is the almost sure convergence? So if you have the sequences of the random variables xi that defined on the sample space S. So this sample space may be the finite or it may be the infinite. Like here, if you toss the coin, what is my sample space? This is nothing but my head and tail. If you throw a dice, what is your sample space is this is 1, 2, 3, 4, 5, 6. That's the meaning of this sample space. Then I assume S is my finite, so it consists of some finite values are there. Like in case of the tossing the coin, it's a head and tail, so this is S1 and S2. In case of the throwing a dice, it is 1, 2 up to 6. So this is my S1, this is my S2, and this is my S6, and so on. So once you have defined this random variables, so what is the definition of the random variable is? What is the definition of the random variable? It's a set of the outcomes. This is the set of the outcomes to the real numbers. So whatever the outcomes you have taken, these are my outcomes. So you can assign any of the real numbers out there. Once you can assign this real number to them, then definitely this SI is one of the outcomes. So we can say if Sj is the outcome of the experiment, then we can obtain the following sequences are there. Like if we substitute I as a 1, 2, and so on. Now once you are defining the sequence, this is my sequence. So what is the first question come in the mind? The first question is that whether this sequence converges or not. If this is converges, then to what limit it will be there. So that is, we will talk about its convergence. So once we will talk about the convergence, in that case we will discuss about the almost sure convergence, that is the AS. So before defining what is the almost sure convergence, let's discuss with some examples so that you may able to understand the concept. Assume that you have the fair coin and you toss the one time. So if you toss the coin one time, what are their outcomes? That's outcomes are either head or tail. So I can say outcomes is either head or tail. So corresponding to this head and tail, we define the sequences xn like here. Now you can see, now since this is a sequence, so can you say that the sequence corresponding to the each outcome, that is a head or tail, converges or not? If it is converges, then we will see what is the limit of this. So clearly says that, so when you can see when your outcomes is my head, what will happen if your outcome is h, then your sequence will be here. So it means it will be 1 by 2, it will be 2 by 3, it will be 3 by 4 and so on. And you can see this converges? Yes, it is a convergent sequence. You can apply the ratio test if you want. You can apply the ghost test, or any of the tests are there. You can see when outcome is head, then the following sequences are obtained, and you can easily see that this is converges to the 1. You can also see what is the limit as n approaches infinity for this. It is nothing but my 1. So it means this sequence, when it considered as a head, it converges. On the other hand, when you consider as a tail, then what are the outcomes are there? Its outcomes are either -1, either the +1, -1, +1 and so on. So which is oscillating, so which is not convergence. It means this sequence will converges only when head appears. So therefore, what is the meaning of this? So if I consider this as a h or this as a, so this what is the s size? This s size only for the h. Therefore, the what is this set is nothing but my h. What is the probability of the head when you toss the coin is half. So the right answer of this is half. So what is the concept in this example? So you have seen that the sequence is xn converges only when s is h, but does not converge when s is h. So in that case, in general, what we can do is, if you have the sequence is xn, if it is converges to the s, it means if you have this sequence and if you converges this to the x of the s, then we will call as this almost sure convergence. And if you define the probability of the limit n converges to the infinity, xn of this is my 1 is equal to 1, then only we can say this converges to the almost sure convergence. We will denote it as here. We will discuss the 7 or 8 examples in this video also, so that you may understand this. Now what is the definition of the almost sure convergence is? If you have the sample space and their outcomes are there, if you define as a limit of the xn is equal to x and the probability of this set is nothing but the equality 1, then we can say this is this xn converges to the x almost sure convergence. And once you are defining this almost sure convergence, we will call as the strong law of the large number hold for this xi series. Look at this example one more. You have the sample space S between the 0, 1, and you have defined the sequences like this way, and x is another way here. Can you show that xn converges to the s? That's very simple. You have to think about that. What is your target is? Your target is to prove this number will converges to the x of probability 1. That's your target. So for that, what you want to prove that? So firstly, you have to consider what is the xn. This is my xn, this is my s. So I consider the set A as all those elements in the S here. So our target is to prove P of A is 1. Now what is the value of the S? So you can see S is either is a 0 is my closed interval, either here, either S is my half to 1 because maximum value is my 1, or S is my half. So there are the 3 cases are there. So we will consider each case one by one and define the value of the A. So let's consider the first case. So we will firstly find the S corresponding to these B. So when S belongs to the 0 to half. So when S belongs to the 0 to half, you can see the value of the XS is here. And for here, you can see this number I can write like this way. Yes, you can write like this way. So what is the meaning of that? So this here is definitely lies in between because it's a half plus something is there. So this n plus 1 upon 2n, this number is definitely be greater than of the half. So we can say S belong to the here. Now once it is this, you can see what is the value. If any number lies here, what is the answer of the xn? This is 1. Whenever S belongs to the, it's not be here, it's a 0 and 1 by 2. Whenever s belong to this, what is the value of the xs? Is a 1. So it means both are same, it satisfied this property. So therefore this s is belongs to the A. So once it is belongs to the A, as per the definition of the almost shear convergence, the probability is my 1. Look at the second case, when s is greater than 1, greater than half. What is the value of this when s is greater than half? Is a 0. So now our target is to check whether xn also be a 0 or not. So 1, this will be there. So what you can do, 2s minus 1 is always be greater than 0. Now from here, can you think about that? This is my this value. So can I write here as s minus half is 1 by 2n, or I can write here as a 2s minus 1 is 1 by n. So if 2s minus 1 is greater than 0, can I say this is always be greater than 0? Yes, because this is the positive quantity are here. So I can write this as, for n is greater than of this, xn will always be a 0. So what we can do that, if xn is 0, what is the limit as n approaches 0? It is also be 0. Can it be equal to the x of s? Yes, true, because whenever s is greater than here, so again it satisfied this. So what you can do that is s is open interval of half comma 1 that belongs to the A. What is the meaning of that? Probability of A is my 1 in this case also. Look at the another cases. What will happen if s is my half? So if s is half, what is the x of s? So you can see x half does not belong to them, so it will be a 0. What is the limit of the here? So is half belongs to this or not? Again you can see that I can write here as of this 1 by 2n. Sorry, it is not with the equality. So what you can do that, you can see this is half plus something, so definitely as half belong to this. So what is the meaning of that? This value is my 1. Are they equal? No. Therefore you can say x of n half is 1 for all the n, while x of half is 0. What is the meaning of that? S, since this value limit xn is not equal to the x of s as n approaches infinity, so s does not belong to the A. So therefore you can see what is the A is my closed interval 0 to half and open interval to this, or you can say all those values are here. So in that case probability is my 1. So therefore xn converges to the x almost surely. So however the way we have discussed here is very tedious, or you can say is a very time consuming in order to prove this by consider all those cases. So in order to avoid this, we will define some sufficient conditions for the almost shear convergence as here. That is, if you want to prove xn converges to the x bar almost sure, we have to prove like this way. Xn minus x bar is greater than is finite value are there. This means it's a finite. How you can prove that? So you can see how you can prove that. So your target is to prove xn minus x bar is must be less than. So firstly you have to find what is the x bar. You can see can x bar, what is the value of the xn? This is minus 1 by n or plus 1. The probability will be my half and half. So can you find the mean of this xn? It is nothing but my minus 1 by 2n plus 1 by 2n. It will be my 0. So it means I can say this number is my 0. So I can assume here as this. So your target is to prove xn minus 0, it will be here. So that's very simple. You can start from here. What is the mode of the xn? So as I see, xn is my either minus 1 by n or plus 1 by n. So the mode of this here. Now I can start from here. If I start from here, what is the meaning of that? This is here. Okay, so you can see this is greater than epsilon hold if and only if n is less than epsilon. Why? Because what is the mode of x? This is here. So this will be hold only when n is less than epsilon. So therefore we can start from the left hand side. What is the limit on the left hand side are there? So this is infinite. Definitely it will be less than of there is there 1 by epsilon. What is the value of this is it's nothing but my, this is a finite value, so it will be 1 by here, and it's a finite number because epsilon is a greater than 0 is a positive number, so it will be a finite. So you can say this this xn sequence converges to their x bar. So what is the mean of the x bar is nothing but my 0 as almost sure. So this is the way you can check whether the almost sure is a nice manner. However, so sometime what will happen if instead of this finite value, if you got as equality 0, because this is only for the sufficient condition. So then we will not discuss about the almost sure or not. For handling this, we will provide the necessary and the sufficient condition as here. So we can say xn converges to the x almost sure. We can define the set an like here, and if you prove that probability is 1, then we can say xn converges to the x almost sure, and this is the necessary and the sufficient. For example, like here, if what is given to you, xn follows the Bernoulli distribution. So can you find the mean of these? What is the mean of the Bernoulli distribution? This is nothing but the p. What is the p is here is 1 by n. So we can start from here. So since epsilon is always be greater than 0, so Bernoulli takes only 0 and 1 value. So what is the meaning of that? This is nothing but my 1. What is the probability of the Bernoulli when it is a 1? So it's a p, it's a 1 minus p. So what is the probability of the Bernoulli is given to you? 1 by n. So what is that? You can write as a 1 by n. So what is that? This is nothing but my divergent series. So once it is a divergent, you can see it's infinity. Now you can see it's a equality. So it means this second part is there. So can you check whether this is there? So we can't say anything, because if it is less than finite value, then it's a almost convergence, but it does not be. So what we can do is we will define here. You can see what is the mean of this is here. We can start with this one. Now we can define xn as a 0 for all n greater than. Our target is to define here. We can start from here, probability of here. So since n is greater than or equal to m, what is the meaning of that? I can write here as a m plus 1 up to this. Now since xi's are given to you the independent, so we can write like this way. And now that's very simple. This is the probability in case of the Bernoulli distribution. So what is that? This is nothing but the previous value and so on. So this will be cancelled out. So what is the remaining part is here. And what is happen when this is my infinite? So choosing n to be the large, so this value will goes to the 0, that is less than or equal to 0. But probability can't be negative, so it means probability is my 0. So therefore as m approaches here, so what is the limit as m approaches 0? Again it will be 0. So therefore we can say this does not converge. Why? If it is goes to the 1, then it is a converges almost surely, but if it is not be 1, then it's a not convergent. Look at the another one is there. Again it is given to you IAD and uniformly distributed. So if xi is, what is the PDF of the uniformly distributed? This is 1 upon b minus a, else is 0. So what is the a and b? So this is my a, this is my b. Can you define the PDF of this is 1 upon b minus a here. What is given to you? You have to find yn converges to 0. What you want to show that yn minus 0 is my finite value. So we can start with the y of n. Since y of n is minimum of this, so what is the meaning of that? Yn is less than of xi's. So we can start with this left hand side. For any y lies between 0 1, what is that? So since yi is greater than here, so what is that? This is here and it is greater than of y. It means each of the xi's is my greater than y, and they are the sequences of the independent. I can write like this way. So what is that? So also what is the CDF? Can I write this term as of this probability of x1 is less than or equal to y? Similarly I can write like this way, this is less than or equal to y, and so on. What is that? This is nothing but the CDF of the y. This is the CDF of the y. So what is the CDF of the uniformly distributed? So CDF of the uniform distribution is x minus a upon b minus a. A and b is my 0, 1. So what is the CDF is nothing but my x. You can see that it is nothing but my x. So you can substitute here. This is nothing but my 1 minus CDF is my y. This is again 1 minus y and so on. So once you will substitute here, you will get this quantity. Now we can start from this value. So this number is nothing but my here. So I can replace y to be the epsilon. Now can you find this as infinite series? So if this is the infinite series, what is that? This is the GP series. So what is the sum of the GP series is a upon 1 minus r. Now you can clearly see that this is a finite value because epsilon is a greater than 0. So therefore this result holds. So yn converges to the 0 almost surely. Similarly, you have to see one more example are there. Consider the sample space of the 0, 1. Now it's again is given to be the uniformly distributed. You define the sequence here and you have to prove this one. That's again very simple. What you want to prove that either you want to prove n approaches infinity of xn is my x, else you want to prove this is greater than epsilon is less than finite and so on. So since it is a sequences are given, so I prefer this limit n approaches infinity. So what is the value of the s? It belongs to the 0, 1. Okay. So it means there are the several cases are there. First case is either it lies between here. Second case is what is that? This is either s is my 0. Now what you can do that? We can start with here. Firstly, when s belongs to the open interval 0, 1. So what is the limit of this? As n approaches infinity, this value is nothing but my 1. So this is my 0. This is nothing but my s, because whenever s lies between 0, 1, this 1 minus s is also lies between 0, 1. And any number raised to power infinity whenever lies between 0, 1, it goes to the 0. So this value goes to the 0, this value goes to the my 1. So the answer is my s, and it is already given that this is my s. So this is here. So it means this property hold for here. Now what will happen if s is 0? So if s is 0, you can substitute here. This value is my 0. This value is my 1 raised to power n. This is always we have 1. So can it be a x of this? No, because s of 0 is 0. It will not be here. So therefore, what is your a? You can see s minus 0. All those elements in the set, but it is not be here. Also, you can see at s is equal to 1, what will happen? So limit n approaches infinity of xn. So what is that limit? N approaches infinity. What is the value of s is 1? So it will be n upon n plus 1. S is 1 is a 0. So what is the limit of this? It is a 1. Can it be x of s? Yes, because s is my 1, so it will be here. So therefore, you can say in this case it will not be there. Hence, what is the element a? That is the open interval 0 of 1, or you can say s minus 0. Probability is my 1. So therefore, we can conclude Sn converges to the s almost surely. So whenever you want to try to prove this convergence is almost surely, so that means we will discuss on the strong law. So the important example of the almost sure is, so we will describe here as of this. So so this is the way you have to understand the strong law of the large number. So make sure that whenever you want to prove anything converges to this as almost sure, you have to prove either limit n approaches infinity of this is here as the x of this, or else you want to prove here, so you want to this of greater than epsilon, probability is must be the less than, and so on. So this is the way you can discuss on the strong law of the large number. So if you want to find some other videos related to the probability and stat, you can simply follow this channel name. Till then, best of luck students, happy learning.